And out there, joy learning will never leave you behind. That is why we are here on a revision show. With me, Wisdom Agbesinyale, as you always know, Wizzy One. Now the exam is fast approaching. There will be a lot of panics, but joy learning is solidly behind you, so don't panic. One of the most important topics in chemistry that is highly examinable is electrolytic cell and Faraday's laws. So here we are going to look at the qualitative aspect, where we look at some explanations to it, and then we use Faraday's laws to do some quantification, that is mathematics. And as we have been doing it, there is a question for you, for which if you are able to solve everything, there is a handsome reward for you. You have seen the question. I'm sure most of you have been able to solve it, and then you are ready. So there will be a call-in session. Get ready for it with your answers. And it's worth 10 marks. If you're able to get everything, there is a reward for you. Electrolytic cell and Faraday's laws. But before we delve into that one, let's look at the question of the day. That is what we are going to solve for your reward. So let's read it together. Sit back and relax, and let's flow. Let's enjoy chemistry together. A current of 1.6 amp is passed through an electrolytic cell containing a dilute H2SO4 solution for 4.4 hours. Write alpha half cell reaction equations, beta overall reaction. So the blank spaces, we are going to use this to solve the questions. B, calculate the volume of gas liberated at the alpha anode, beta cathode at STP. C, state 3 reasons why electroplating is important. And then we have 1F, that is 1 Faraday, is equal to 96500 coulombs per mole. Then we have the molar gas volume equal to 22.4 dm cubed at STP. This is the question of the day. So I'm sure some of you have already worked on it. Some will still be working in the course of our togetherness tonight. Then it is 10 marks. If you are able to get 10 over 10, joy learning will reward you for your effort. So the electrolytic cell, what is it? How does it look like? Bring out your pens and rulers, because we are going to do drawing. So this is how it looks like. It is connected to a power source. And you know the power source has negative terminal and then the positive terminal. So my positive terminal is there, then my negative terminal is there. Then I'll have connecting wires to it. So those are the connecting wires. Then we have the electrodes. Then we dip that into a solution called the electrolyte. So this solution is the electrolyte. This is the source of power. These are the electrodes, and since this electrode is connected to the positive terminal, it will be positive. And the other one, this one here, is connected to the negative terminal, so it will be negative. So the electrolyte is a compound that conducts electricity in its molten or aqueous state. When we say aqueous solution, there is water involved. It means that the substance is dissolved in water. So example, sodium chloride. So when sodium chloride is dissolved, we have the positive and negative ions coming together. So in solution, it will break down into the positive ions and the negative ions. And since the poles are charged, that is, the electrodes are charged, negative and positive, there will be an electrostatic force of attraction between the poles and the ions in solution. So the ions will move to the poles. We have Na plus there. So positive, negative will attract. So you will agree with me that the Na plus will go to the cathode. So Na plus. And this, technically, it is called cation. And then it is moving to the electrode. So it means that this electrode here is the cation electrode. Therefore, the name for that electrode is the cathode. So it means that the cation moves to the cathode and it is negatively charged. So that is how come you say cathode, cation electrode. So it becomes cathode. Then the anion here moves to the positive pole. So Cl minus will go there. So that is anion electrode. So it becomes anode. So the anode is positively charged and the cathode is negatively charged. So this is how you draw and label an electrolytic cell. This is how it looks like. If you want to go further, then you can also name these are the connecting wires. You can also decide to put a switch. You can decide to put a rheostat over there or variable resistor. So if I want to also sketch that one for you to see, then we can have that. So I can put a key there, then I can put my variable resistor there. So we can also have that as you wish. The reason that you want to put variable resistor and then a key could be that this electrolytic cell is highly industrialized. We use it in industry for a lot of purposes. So when you put the variable resistor there, you will determine the amount of current that flows through the electrolyte. Then you can decide to put it off and you can decide to put it on. That is the reason why you can decide to drop a switch or a key and then a resistor just to control at will. What then is an electrolytic cell? So it is a cell or device that produces chemical reactions by the passage of an electric current. And this current here must be a direct current, not alternating current. The flow of current must be unilateral, going in one direction. Other than that, once upon a time, if you are using an alternating current, it means that once upon a time, the anode will go into negative, and that will be cathode. And then the cathode will go into positive, and that is anode. So to prevent that, the current must flow in one direction. And then the electrons also flow in one direction. So that is the flow of current, and that is the flow of electron. So that must always continue like that. Or you can say it is a system of electrodes and electrolytes. So electrodes and electrolytes, in which electric current is used to drive a non-spontaneous redox reactions. Now, the non-spontaneous means that this kind of reaction cannot occur on its own. So it must occur under external force, and that external force is the power source to the cell. So if you do that, the electrolyte will break down into the ions, and of course, don't forget, redox reaction occurs in this cell. So the third definition that you want, reaction system in which redox reaction occurs through the use of electric current. See, so different definitions conveying the same idea. So you choose the one that you want, so that when they ask you to define electrolytic cell, you will be able to successfully define it for your marks. Now, before we continue, you are in an exam and your papers are before you. Your exam paper is before you. You have to have the wisdom of choosing questions. Choose your questions wisely. When they say start work, don't rush into starting work. Take your time, read through all the questions. You have 5 questions, you are going to answer 4 out of it. Read the questions. Maximize your marks. Which of the questions, if I answer it, I'm going to make a maximum mark? Those are the questions you should be asking. So if you are done reading, then you wait. Okay, this and this and this, if I answer it out of this question, I'll have a maximum mark. Always think of maximizing your marks in examination. So choose your questions wisely. Each and every aspect. If you have one that you can answer only 1 out of all there, and then you have another one you can answer 3 out of all there, with a maximum mark, you go for it. Let's continue. You can also define that. So when we have our electrolytic cell like that, every stage I want to draw it so that you get used to the drawing. A question can ask you to do that. So when this is happening, the electrolyte breaks down into the ions that a process. And that process is what we refer to as electrolysis. So for electrolysis, it's a process in which electrical energy is used to cause non-spontaneous redox reactions to occur. Redox because when the ions separate, they undergo oxidation and they undergo reduction. And we said that oxidation is the loss of electron, and then reduction is the gain of electron. So when they go there, they experience redox, loss or gain of electrons. If you are not okay with the first one, then you can go for this: decomposition of an ionic system or electrolyte by the passage of direct electrical current. Now, if it is exams, don't use the system or electrolyte. Use any of them. You are either using ionic system or you are using electrolyte. So decomposition of an electrolyte by the passage of direct electric current, or decomposition of ionic system by the passage of electric current or electrical current. Use one in your exam. We can say it is the process whereby electric current is used to cause redox reactions to occur. Now, the redox reaction occurring, it's all about transfer of electrons. So redox reaction is about transfer of electron or electrons. Now, we have defined what an electrolytic cell is, what electrolysis is. That is the process. There are some aspects we have to also define. So I want to draw it again. By the time we finish this, you should be able to comfortably draw an electrolytic cell. So this is the electrolyte, and these are the electrodes. And we have already named them. So this is the cathode. This is the anode. Because it is connected to the positive terminal, it is positive. Here, it is negative. So what is an electrode? So an electrode is a conductor through which we have already indicated that current going like that, electrons going in the opposite direction. So it is a conductor through which current enters the electrolyte, or current leaves the electrolyte, because this is how the current is going. You can define it in terms of electrons. So you can say a conductor through which an electron enters the electrolyte or leaves the electrolyte. So that is the electrode. Then we can talk about anode and the cathode. So the anode, as we have it here, it is the positive electrode through which current enters the electrolyte, or electron leaves the electrolyte. Then the cathode is the negative electrode through which electron enters the electrolyte or current leaves the electrolyte. And of course, at the anode, there is oxidation. So oxidation occurs at the anode, whilst reduction occurs at the cathode. Now, what is reduction? We have already talked about it. Gain of electron. Then this is loss of electron. So if you are asked to define oxidation, you can just write loss of electron, reduction, gain of electron. The next thing we want to talk about, we have already said that we have an electrolyte. So what is an electrolyte? Electrolyte is a compound that conducts electricity in its molten or melted state or in aqueous state. And when we talk about aqueous, it means water is there. So when the electrolyte breaks down, it produces ions, and the ions carry electrical charge, so they conduct. We can talk about the types of electrolyte. We have the weak electrolyte, then we have the strong electrolyte. The strength, as we know from acids and bases, has to do with dissociation ability or degree of dissociation. If it dissociates completely, then we can say that that is a strong electrolyte. So a strong electrolyte is a compound that dissociates completely. So I can just write complete dissociation occurs here. If complete dissociation occurs, then it means that we have high concentration of ions in solution. If we have high concentration of ions in solution, then we can say that that electrolyte is a good conductor of electricity. Now, we can give examples. The examples, all strong acids, all strong base will be a strong electrolyte, and all salts. We don't have a weak salt and we don't have a strong salt. A salt is a salt. It will dissociate completely in solution, producing high concentration of ions in solution. So if I know any specific example of a strong acid, you can just give it as these are the three most common strong acids in the laboratory. So if you are giving an example, you give these common ones. Other than that, I can also say HBr, HI. They are all strong acids, but they are not common. That is why we always make mention of A2SO4, HNO3, ACl as the strong acids because they are common. We come into contact with it in our labs. Then all strong bases, the first one that comes to mind is the NaOH. I can also write KOH. NaOH is very, very common in our labs. And then the salt, the first one that comes to mind is the sodium chloride. You can have copper 2 sulfates, zinc chloride, and so on and so forth. Right. Then the weak acid means that they undergo partial or slight dissociation or ionization. If they undergo partial ionization, then it means that they will have low concentration of ions in solution. If they have low concentration of ions in solution, then they will conduct electricity poorly. So poor conductors of electricity. And so examples, we can have our very good friend water as the weak electrolyte. We can talk about very common base, ammonia. We can talk about very common acid, ethanoic acid, like that. So these are three examples. So we can also talk about non-electrolyte. The non-electrolyte, they do not ionize in solution. So if they do not ionize in solution, it means that they will have no ions in solution. If they have no ions in solution, then they cannot conduct electricity. So non-electrolyte, they are non-conductors of electricity. So we can talk about sugar, table sugar, can talk about benzene, can talk about ether, can talk about cyclohexane, and so on and so forth. So now the common question that you can have here, the question can ask you to define electrolysis, or define electrolytic cell, or define electrolyte. Then they will give you mixtures of what we saw already, the examples that we have like that, and then these ones. Then they will ask you to classify them into non-electrolyte, strong electrolyte, and weak electrolyte. So the examples I have given, you look at them carefully, so that when you see them in the exams, you'll be able to answer it whilst you are smiling. Okay. Now, what else can we talk about? Let's talk about discharge of ions at the electrodes. In other words, this one is guided by ionic theory. That says that when you dissolve an electrolyte, the electrolyte, either some or all of them, dissociate into free moving ions. So that if I have NaCl in water, it will dissociate into free Na plus aqueous and Cl minus, so dehydrated ions. When this happens, because they are under external force, they move to the electrodes. So electrolytic cell has become our friend today. Okay. Here. So these ions are there. This is positive, that's negative. So the negative pole will be attracted to the positive ion. So it means that the positive ion will be driven to the negative pole. And then the negative ion will be driven to the positive pole. So here, what happens? That is where the redox reaction occurs. The loss or gain of electrons occur. So here, because we said that it is in solution, it means that water is part of it. So if I want to expand the size of my electrode, like that. So if we decompose the ionic system, it is in water. So water will also break down into the ions. Like that. So the cations will go to the cathode. The cations they are positive, then here is negative. So they'll move to the cathode like that. And then the anions will move to the anode like that. Now there will be competition between the ions at the anode. Who will leave the electrolyte? And how will it move? What happens when they move? This is what we are referring to as a discharge, because they leave the electrolyte. Now this discharge are governed by factors. So factors affecting the discharge of ions at the electrodes. Number one, we can talk about concentration. Of ions. So that, for example, if you have a sac like that, then I have maize inside. Then I have granules also inside. If the granite is more than the maize inside the sack, and you put your hand inside the sack, which of them is likely to be picked by your hand? No bias, no feeling of it. Oh, this one I can feel it as granite. This one I can feel it as maize. Just dip your hand inside, you pick. Because the granite, for example, is more than the maize, it's likely that you pick that. So in the electrolytic system, when the ions are concentrated, that one is likely to be discharged. And that also is affected by distance between the ions on the electrochemical series. How far are they there on the series? That will also determine whether, if you are concentrated, you'll be discharged or you'll not be discharged. So the second one, we want to talk about the position of ions on the electrochemical series. So that position also affects the discharge. So for example, for the cations, from left to right, it is K plus, Na plus, so that's the arrangement of the cations. And we know that the cations go to the cathode. So this is where hydrogen is. This is where sodium is. So if sodium and hydrogen are in solution, hydrogen will always be discharged, because as you move from left to right, the preference for discharge increases. And it's also decreasing in electropositivity. And we have to gain an electron to be reduced. So if you are less electropositive, you can easily gain an electron than if you are more electropositive. So sodium up here is highly electropositive than hydrogen. So if sodium is in competition with hydrogen, hydrogen will go, whether we have high concentration of sodium ions in solutions or not. That is for the cations. Then if we are talking about the anions, we can have the F minus, the SO42 minus, NO3 minus, Cl minus, Br minus, I minus, and then OH minus. So that is increasing from left to right, increasing preference of discharge. And in that direction, it is decreasing in electronegativity. So the more electronegative you are, you find it very difficult to lose an electron. If you are less in electronegativity, you can easily lose an electron to undergo oxidation. So if, for example, F minus and OH minus ions are in solution, the OH minus ions will be discharged as oxygen gas in preference to F minus ions. However, if Cl minus and OH minus are in solution, we can talk about the concentration. If we have high concentration of Cl minus ions in solution, they will be discharged in preference to the OH minus ions because of concentration and closeness of the distance between the Cl minus and OH minus ions. The distance, there is no measurement of it, that this is the distance. If you measure and it falls within that distance, it means this will happen. We are looking at it as a very common substances that we can lay our hands on, so that the Cl minus there can easily come from sodium chloride for us to use. So between Cl and OH minus ions, all other anions within there, when they are in high concentration, they will be discharged in preference to OH minus ions. When the rest are in competition with OH minus ions, they will never be discharged. So you take note of that one. Right, so what happens when the discharge is occurring? So let's pick few examples and see. So if, for example, we want to electrolyze dilute sodium chloride, the decomposition process will be NaCl moving to Na plus Cl minus. Aqueous, dilute, so it means there is water. So you dissociate water also to be H plus plus OH minus. So the ions are in solution. Now, we are using only forward arrows. The NaCl is a salt, so it will dissociate completely in solution. Now, the water is a weak electrolyte, so you might be tempted to use reversible arrows. This water is not undergoing autolysis. It's not breaking down on its own. It's breaking down under an external force, so it can only go forward. It cannot come back. So if you want to be very sure of it, then you can write on the arrow electrolysis to be at the safer side. Right. So the sodium and the H+ ions, they go to the cathode. We are talking about dilute solution. So dilute solution, and H+ is coming from the solvent, and of course we have higher amount of solvent in there compared to the solute. Therefore, H+ will be discharged at the cathode. How? So at the cathode, we have Na+ and then H+ at the cathode. So the reaction there will involve H+ ions. So we said that at the cathode, reduction will occur. That is gain of electron. So H+ ion will gain an electron to produce H atom. But H atom to us is intangible. We can't use it for anything. But to us, we want to make society better. So we have to get something tangible for the betterment of society. So because of that, if we are talking about H atom, what use is it to us? And we don't have only one H atom at the cathode. Therefore, another H atom can undergo reduction. So another H+ atom is receiving an electron to produce another H. So if I add the two equations together, I'm going to have 2H+ plus 2E- producing H gas. Yes. So the H gas is useful to us. So it means that the cathode reaction will involve 2 moles of H+ ions gaining 2 moles of electrons to produce 1 mole of H2 gas. So in terms of volume at STP, it means that I need 2 moles of electrons to be transferred to give me 22.4 dm³ of H2 gas at the cathode, and that comes out as a gas. So if you are asked to write the cathode reaction, you're going to have 2H+ plus 2E- giving us H2 gas. At the anode, this is what happens at the anode. The anode, we have Cl- and then OH-. Who goes? This one is less electronegative, so it can easily lose an electron. So it will undergo oxidation. That is the OH- ions. So with the OH- ions, so anode reaction the OH will go out as oxygen gas, because oxygen gas is tangible. It can be packaged for our hospitals, for emergency cases. Yes. So we are looking for oxygen gas. So how many or how much of the OH minus ions will undergo oxidation for us to produce oxygen gas? So at the anode, we have OH minus ions losing an electron to give us the OH molecule. Another one can also lose electron. So OH minus giving us OH plus that. If I put these two equations together, I'm going to have 2 OH minus to 2 OH plus 2 E minus. So if I transfer 2 moles of electrons, I'm going to produce 2 moles of OH minus molecule. And out of the 2 moles of OH minus molecule, I can produce water, so H2O. So to balance it, I'm left with oxygen atom to balance it. But what are we going to do with oxygen atom? We have nothing to do with it. So we have to drive towards getting oxygen gas. So if that is the case, then I can also have 2 moles of OH minus ions producing 2 moles of OH plus 2 moles of electrons. And this one will also give us H2O plus O. So if I put the 2 equations together, I'm going to have 4. This is 2 there, 2 there. And then 2 electrons, 2 electrons. So I'm going to have 4 OH minus ions and then 4 electrons to give me 2 moles of water. And of course, a tangible substance, oxygen gas, that we can use. So if I put them together, the anode reaction will be 4 OH minus ions producing 2 moles of water plus oxygen gas plus 4 electrons at the anode. What I'm doing, we are just making you to understand where you see in your books 4 OH minus ions producing 2 H2O plus O2 plus 4 E minus. So this is how the 4 OH minus ions producing 2 moles of water, 1 mole of oxygen gas, and 4 moles of electrons. This is the explanation to it. It doesn't mean that when you see this in an exam, you should do what I'm doing. I'm just explaining to you. So the next time you see 4 OH minus ions producing 2 H2O plus O2 plus 4 E minus, you know how it was arrived at. That is the beauty of chemistry. You get that? Yeah, so let's continue. Right, so if they say you should write anode reaction involving what we are looking at currently, sodium chloride being electrolyzed, we just write the 4 OH minus going to 2A2O plus O2 plus 4E minus. And then for the cathode, you write 2H plus plus 2E minus moving to H2 gas. That's all. The next thing you want to look at is the overall equation. So the overall equation, we have for that. Then we also talked about produce H2 gas. Now from redox reactions, you need to make the electrons equal. So I have 4 there, I have 2 here. So I have to multiply here by 2. So if I multiply there by 2, my overall equation is going to be 4OH minus plus 4H plus moving to 2 water plus 2H2 plus O2. So don't forget here the electrons will be 4. So the 4 there in my left hand, 4 there in my right hand will cancel out. So this is my overall equation. But you need to simplify them. This is 4OH minus ions, 4H plus ions. So I'm going to produce 4 water going to 2H2O plus 2H2 plus O2. So I have 4 water here, 2 water here. So in effect, I'm going to have 2 water producing 2 moles of hydrogen gas plus a mole of oxygen gas. So at the end of the day, it's as if we are only electrolyzing water. Beautiful. Yes, very beautiful. Now, what else can we do from here? So if you are asked to write overall equation and you write 4 water producing 2 water and then 2 H2 and 1 O2, you have to simplify. That shows that you have command over what you are doing. Right. What next? We want to determine the state of the electrolyte. The electrolyte, what will be the pH of the resulting solution when electrolysis occurs? Is the process of sodium chloride undergoing electrolysis environmentally friendly? What will be the effect of the resulting solution on indicators? Let's look at how to deal with such things. So, OH minus has left as oxygen gas. So I have Na plus, OH minus, Cl minus, H plus. These were the ions in solution. OH has left as oxygen gas, so it's gone. And then H plus has also left as H gas, hydrogen gas. So we are left with Na plus plus Cl minus. So they will combine to form the salt. So it means that at the end of the day, the solution will be more concentrated than before. Now the Na plus is a cation from a strong base, and then the Cl minus is an anion from a strong acid, HCl. Because of that, they don't undergo hydrolysis. So if they don't undergo hydrolysis, the resulting solution will be neutral. So the pH of the resulting solution will be 7. Therefore, it will not have any effect on indicators, litmus paper, phenolphthalein, metal orange. Now, is the process environmentally friendly? How do I determine that one? Look at the gas involved at the anode and look at the gas involved at the cathode. So most of the cases, because oxidation occurs at the cathode, gases are produced. Sometimes at the anode, gases are produced because oxidation occurs there. At the cathode, sometimes gases are produced, especially when hydrogen is involved. Sometimes it is a solid deposit. So in case there is a solid deposit and a gas at the anode, you consider the gas. Is it poisonous or not poisonous? If it is a non-poisonous gas, then it means that the process is environmentally friendly. If not, not friendly. So that is how. What are the ions in solution after the electrolysis? You combine them and know the state of the solution. That is how you do. There are many we have to look at. The third factor that influences the discharge of ions at the electrode is the nature of electrode. So the nature of the electrode can be active or inert. If it is active, it will take part in the electrolytic process. If not, it will not take part in the electrolytic process. Then we say this electrode is an inert electrode. So examples of inert electrode, you can have platinum and then graphite. For active electrode, you can talk about the metals, copper, zinc, and so on and so forth. And the last factor is the size and duration of current passed. So with the size and duration of current passed, that will take us into the calculations using Faraday's laws. The more current, the higher the amount that you are going to discharge. If you allow more time for it, you are going to discharge more. So if that is the case, then we should quantify how much are we going to get within this duration. Right, so let's move to the next item. This, what we are doing here alone, can take the whole time because there are other examples that we have to look at. So let's move to the other side. Application of electrolysis. Very, very important. I told you that it is highly industrialized. Many beautiful things you see around you are electroplated substances. So don't be deceived. Somebody will go and buy a necklace or whatever, and then will tell you this is pure gold. No, it's not a pure gold. That is why within a short period of time you say, my necklace is fading. How fading? That is electroplated substance. You are wearing, you say it is pure gold. Who told you? So please don't be deceived. Right, so the first one is electroplating. Here we use an inferior metal as the base, then a superior metal is used as a cover. So you cover an inferior substance with a superior one. So you see the surface, say, wow, this is beautiful. This is pure gold. Hey, take it easy. Don't be deceived. It may not be a pure gold. So how is that done? Very simple. We use electricity. So the diagram remains the same. What are you electroplating? So electroplating is just the process of depositing a superior metal on an inferior one by using electric current. Take note, this electric current must not be an alternating current. It must be a direct current so that the flow of current will be unilateral, one way. Okay. So let's say we want to gold plate. So gold plate what? Maybe earring, right? So you put the earring at the cathode. So that is my earring. Yes, that is my own. Okay. At the cathode. So this is the earring at the cathode. Then you put a gold metal at the anode. And then you use a soluble gold salt as the electrolyte. So most of the time we use gold nitrate as the electrolyte. So when you turn on the power source, the gold metal here becomes an active electrode. So it will enter solution as gold ions. Positive, it will move to the negative where the earring is and go accept electrons there and get deposited on the earring. That's all. So you have gold plated. You see it, wow, this is gold. Don't be deceived. It could be a gold plated something. So even if you want to electroplate a human being, just put the human being at the cathode, put the gold at the anode, use gold salt, soluble salt solution as the electrolyte, turn on your power source, human being will be covered with gold. That is, the human being can conduct electricity. So that is how it is. It is done, highly industrialized. So most of the beautiful things you see in your homes, they are electroplated. You can use copper to do the electroplating and so on and so forth. So the next time you are wearing watch and then that part of the watch is so shining, it could be silver plated, it could be chromium plated part of the watch that you are using. The door handles and so on and so forth. So that is how it is. So if examination says describe how any named thing, maybe pen or whatever, is plated, you should have that. The substance to be plated is set at the cathode, the plating metal anode, the plating metal salt solution should be used as the electrolyte, and then you connect it. So it can be done in the lab. It's not theoretical, it's highly practical. Right. Number two, extraction of metals. These metals are extracted using electrolysis. So if, for example, I have concentrated sodium chloride, we call brine. So with the brine concentrated, so Cl minus will be produced at the anode and then H plus hydrogen gas added. But if I have molten sodium chloride, there is no water there. So this one is liquid. If you have ever seen magma before, volcano is molten rock. So if I have molten sodium chloride, I'm going to have Na plus plus Cl minus. You see. So here there is no competition. So the sodium metal goes to the cathode and then Cl minus goes to the anode. Cl minus go into Cl2. It will lose 2 electrons. and then the Na will gain 1 electron to the metal. So this metal will be deposited at the cathode. So you have produced sodium metal. Sodium metal is very soft. You can cut it with a knife. And when it reacts with water, it produces sodium hydroxide. And of course, it will have effect on indicators. So you can write the balance equation between the reaction of sodium with water and to produce that plus hydrogen gas. So you can balance it. Enjoy yourself with it. Number 3, purification of metals. These are highly industrialized processes. So if I want to purify metals, the process is also simple. What should I do? I have my cell. So put a thin pure metal at the cathode, and then put the metal block that contains impurities at the anode. When you turn on the power source, the anode becomes active electrode. So it will enter solution. So if, for example, I'm purifying copper, I can have Cu metal going into Cu2+. So this one contains impurities. It's at the anode. So it will go into solution as Cu2+. Go to the cathode there and gain 2 electrons, and it is deposited as copper metal. So that is pure. The impurities remain in solution. So at the end of the day, as the process is going on, the anode will be decreasing in size. So everything will dissolve and be deposited at the cathode. Then if it is over, take it off. You have pure metal. So electrolysis can be used. So the exam question here can ask you state 2 industrial applications of electrolysis. Then you write it and you go. 3 applications, you write it, you go. Describe how you purify a named metal. Put the impure metal at the anode, little pure metal, just a point to deposit at the cathode. Use the metal salt solution and then turn on power. The anode enters solution. As ions is deposited at the cathode, you have purified. And the last one, preparation of compounds or elements. When we saw the illustrations, what did we do? We got hydrogen gas, we got oxygen gas. Now, if we want to electrolyze concentrated sodium chloride, now because it is concentrated, the competition between Cl- and OH-, Cl- is highly concentrated, so it will be discharged. So Cl gas will be evolved at the anode. And then at the cathode, we have H+ there. NaCl is highly concentrated, but Na is highly electropositive than H+. So the H+ can easily accept electrons to get reduced into the gas. On the other hand, the energy to reduce the H+ is less, much less. So where will you go? Cheap side, a low energy, so it will get reduced as a gas. Now when that happens, we have these ions in solution. take note, we are talking about electrolyzing concentrated NaCl. So if that is the case, this one is going, this one is also going. So we are left with Na plus and then OH minus in solution, which will combine to give us NaOH. So this can be concentrated, crystallized to give us sodium hydroxide. So if you have salt solution, brine, as we call it, concentrated salt solution, you can produce sodium hydroxide. You can produce hydrogen gas. You can produce chlorine gas. So it means that the sea we have there has a lot of things that we can do. The plenty salt deposit we have, we can get a lot of chemicals from it. And that we can import from Ghana. Now let's look at the calculation aspect where we want to talk about Faraday's laws. So we want to define Faraday. Please take note, all we have done so far, there are lots to it, but time. So we have to. So with the concept, use it and go and apply to others. What is Faraday? It's a charge on 1 mole of an electron or singly charged ion, and it has 96500 coulombs per mole. Because it is per mole, it means that Faraday is a molar quantity. So this is telling us that 1 mole of an electron carries a charge of 96500 coulombs. Take note, we are going to do calculations. So if it is a singly charged ion, then I can have Na plus gaining an electron to produce Na solid, that is metal. So here, 1 mole of electron producing that. So I need 1 Faraday to deposit that amount of sodium metal. Now, if I ask you to calculate the molar mass of Na, you tell me it is 23 grams per mole. So this one, molar mass, is also a molar quantity. 1 mole contains that gram. So if 1 mole contains these grams, then 1 mole of electron being transferred to produce 1 mole of Na, I will need 96500 coulombs to deposit that mass, 23 grams of sodium metal. So you take note of that. So that if I have a metal M with a charge N plus, I will need N electrons to produce or deposit the metal solid at the electrode. So I will need N Faraday quantity of electricity to deposit 1 mole of the metal. So if I want to calculate the quantity of electricity needed, I will have the moles of electron transferred times the Faraday. You just multiply, then you are good to go. Now let's look at the laws. Faraday's laws of electrolysis. This one easily comes in as exams, so take note of it. The mass of an element discharged at the electrode is directly proportional to the quantity of electricity passed. You see, so if that is the case, then mathematically we can have mass is directly proportional to the quantity of electricity. So if that is the case, quantity of electricity is the time, current I, then time t. The time t should always be in seconds. So if they give you time, you should change it to seconds. They give 15 minutes multiplied by 60, 15 hours multiplied by 3,600 to give you in seconds before you do whatever substitution you want to do. So that is the first law, and I said it is very common in exams. The second law says that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of element discharged are inversely proportional to the charge on the ion. So number of moles is inversely proportional to the charge. So if I say the charge is Z on the ion, then that. This is the second law. So take note of it. If exam says define the second law of Faraday, you go for it. If it is the first law, you go for it. Let me tell you this one. Definitions are definitions. In chemistry, there is nothing like the student has the idea, so give him 1 out of 2 or half out of 2. You either get the mark or you lose. You see, so if you do the definition anyhow, you may not get the mark allocated. So get the right definition and do the right definition whenever you are called upon to do that. Okay, so we can solve some questions. So this is the first one I call examination style questions. Calculate the mass. So we are looking for the mass of copper deposited at the cathode when copper 2 sulfate solution is electrolyzed between copper electrodes by current of that and then that. So with the current, since we are coming to do mathematics, get your calculator ready as we do the mathematics. Don't forget the solution to the question problem of the day. I'm sure you are ready and itching to bring the answers for your handsome reward, right? Okay. So there are many ways of solving these questions. There are 3 ways. We can use ratio and proportion. Out of that, we can have formulas to work with, and then some other ways. So let's look at it. What do I have? Whenever you see a question like this, you ask yourself, what have I been given? We have the mass of copper given, that is relative atomic mass. We have the Faraday given. In the question, we have current and we have time, 1 hour. So this one, you change it to seconds. So from here, from the definition of the first law of Faraday, we saw that the quantity of electricity is equal to IT. So I can calculate the quantity of electricity there using 10 times 1 hour, but change it to seconds. So times 60 times 60. So that is 3,600 times 10. So 36,000 coulombs of electricity. So from there, I can use ratio and proportion. So 36,000 coulombs. Now, if I want to use ratio and proportion, this is what I have. I've been given that 1 mole carries 96500 coulombs of charge. So I have to write the equation which we know already, because copper is undergoing reduction. So it will gain 2 electrons to go into the copper solid. So it means that here I need 2 moles of electrons to deposit 1 mole of copper, or 2 Faraday to deposit 1 mole of copper. And of course, that is the mass of copper being deposited. So I can say that I need 2 Faraday to deposit the mass of copper. So if that is the case, how much will 36,000 coulombs of electricity deposit? So I can have that one. So from here, this 1 mole has a mass of 1 mole of copper. So 1 mole of copper has 64 grams. So I can do ratio and proportion here to work it out. So I can say that 96500 coulombs of electricity deposits the mass, because it's 1 mole. So the mass 64 grams of copper. But we need 2 moles of electron to be transferred. So it means that I'll have to have 2 Faradays. So 2 times to deposit that. So if that deposits, then 36,000 coulombs will deposit how much mass? So I'm going to have 36,000 divided by 296,500 times 64. And that should give me an answer. So that is the ratio and proportion I can. So from here, we can derive a working formula for working. So you just put your formula, you do the substitution. That is if you want to memorize the formula. But you can always use ratio and proportion. So let's look at it. So you have your calculator. What do we have there? So I'm going to have 36,000 times 64. Then you divide it by 2 times 96,500. So if you do well and you agree with me, I can have it in the nearest whole number. That will give me 12 grams. So that is the mass deposited when we use 10 amps of electricity for 1 hour in electrolyzing copper sulfate solution. Now that brings us to the industrial aspect of it. So if you are the chief chemist there, the industry will agree. We are doing electroplating of earrings. How much of copper can we deposit to maximize profit? So you will sit down and do the calculation. Here we are using 10 amps of electricity within an hour. So if you do that one, you are going to deposit 12 grams That's huge. You will cause financial loss to the industry. 12 grams deposit. It's heavy. So you do the calculation. Let's say the industry, the MD says that with this earring, to ensure quality of the earring, let's deposit 0.005 grams of copper. So with that, you use it to calculate the amount of electricity you must pass and then how long you should pass it to deposit 0.005 grams of copper or of gold or of whatever chromium or whatever you are going to use it for. You see, so that you do the calculation and you are perfect. Okay, so let's derive a formula from here. The 36,000, what is that? That is the current times time in seconds. So IT. What are we looking for? We are looking for mass. So mass equal to IT. What is this? That is relative atomic mass, and of course it is the molar mass of the metal. So molar mass on what is this? That is the charge Z. 96500, that is Faraday. So this is our working formula. If that is it, I can rearrange this formula to give me mass on molar mass equal to IT on ZF. So this is a working formula. Now you know from mole concept that mass on molar mass is equal to amount of substance. So that, and then you agree that solutions concentration times volume will also give me amount of substance. Then you agree with me that number of particles divided by Avogadro's number will also give me number of moles. Then you agree that volume divided by molar gas volume will also give me N. So if I should enter state of matter, then you agree that PV is equal to RC. You see, I call this forget me not. So if you are able to keep this one, you can work any question. You take your time, bring out the parameters, choose the right connection, do your substitution, and off you go. So take notes, don't forget that one. Is that okay? So with this one, you can be asked to calculate time, asked to calculate current, the charge, and even the quantity of electricity that is needed, and so on and so forth. So take note of the formula if you want to use the formula. This is another set of questions that says a piece of jewelry is to be gold plated by electrolysis using gold nitrate solution. Draw and label a diagram to show how this could be done. And of course, we have drawn it over and over and over. So this one, you can even close your eyes and draw it. If a current of 0.4 amp is passed through the solution for 30.6 minutes, calculate the mass of gold deposited on the jewelry. See, so this is industry. No financial loss. So let's take a breather. When we come back, we'll solve this question and we'll continue. Stay tuned. think there is problem with the hello.
Examination malpractice is any form of deliberate cheating on examinations which provides one or more candidates with an unfair advantage or disadvantage. It is an illegal act and can be perpetrated by a single individual or groups. It can occur outside or inside the classroom. So before you enter the exams hall, make sure you follow these instructions. 1. Empty your pockets and avoid entering with a foreign material, that is smuggling of answer scripts. 2. Avoid writing on sheets of papers, handkerchiefs, erasers, covers of calculators, and on the skin. Remember not to fall victim to any examination malpractices so you could have a peaceful examination. Prepare well, and we wish you all the best. Joy learning, keep learning.
For a new way to revise for your WASI, then Joy Learning has everything you need in place. Yes, we are back with the 2023 revision show for SHS 3 learners. Don't worry, your favorite question of the day section wasn't left out. And oh, you can engage with your facilitators during live TV lessons, ask questions, and get real-time feedback in the comfort of your own space. The 2023 revision show for SHS learners shows every Monday to Friday at 7:30 p.m. right here on Joy Learning. Joy Learning, learning is so fun. Joy Learning, keep learning. Are you
Examination malpractice is any form of deliberate cheating on examinations which provides one or more candidates with an unfair advantage or disadvantage. It is an illegal act and can be perpetrated by a single individual or groups. It can occur outside or inside the classroom. So before you enter the exams hall, make sure you follow these instructions. 1. Empty your pockets and avoid entering with a foreign material, that is smuggling of answer scripts. 2. Avoid writing on sheets of papers, handkerchiefs, erasers, covers of calculators, and on the skin. Remember not to fall victim to any examination malpractices so you could have a peaceful examination. Prepare well, and we wish you all the best. Joy learning, keep learning.
Right, you are welcome back. And I'm sure the question we wanted to look at before we went on break, you have already finished solving from all we have done so far. So we want to quickly look at it. But don't forget, the beginning, I said that there is a handsome reward for you. Based on the problem of the day. So if your answers are ready, I am ready. You can get through to us on take it, and call me. I want to chat with you. Yes, 03022111705 or 706. Let's get interactive. You and you and you spending time with me. Okay, so let's solve this one. However, if your answers are ready for the problem of the day, you can get through. And let's see if you receive the award. Right. So, as I've been saying, this is the question before us. What have we been given? What are we being asked to do? And what do we know? We have all the formulas, we have all the scientific principles, and so on and so forth. We have them. So all we need to do is to get our parameters from the question. So here, they say we should draw and label a diagram to show how this could be done. That is electroplating of a jewelry. And then current is given, time is given, and we are looking for mass. We have been given Faraday, we have been given mass of gold. So question is solved. Okay, so the diagram, as we know, I'm sure you have finished drawing the diagram because we have done it over and over. So now it should be part of us. Okay, so the positive terminal there, a negative terminal there, connecting wires. The jewelry, they say the jewelry, we don't know what it is. So maybe it is a necklace or whatever it is. Then we connect that also like that. Then we use gold nitrate as the electrolyte. So gold nitrate as the electrolyte. They say we should label, so you have to label everything. So this is the jewelry. That is the gold nitrate solution as the electrolyte. That is the gold metal, and then this one here is the power source. So here is the power source. You can bring in here as the connecting wires and so on. So if you label them rightly, we can say here is one, here is one, here one, here one, here one. So this is how it is done. So that when the current is on, the gold at the anode enters solution, and then it is deposited on the jewelry there. That's all about it. Now we have to calculate the mass on the jewelry. We have the current to be 0.4 amp. Okay. Good evening, Ewenam.
Hello.
How are you?
Mr. Fine.
You are welcome to the show. And I'm happy to have you on the show.
Thank you.
Are you ready with your solution?
Hello.
Hello?
Yes, I can hear you.
Hello, hello?
Hello.
Can you hear me now?
Please no.
Oh, hello,
Hello.
hello. Can you hear me now?
Like the line is breaking.
My line is breaking. Oh, sorry. Hello.
Yes.
Can you hear me now? Hello? Oh, everyone, please kindly call back because I want to really have a chat with you. Maybe you are the one who is taking the award on the show. So please come in again, and others get in quickly and let's enjoy. So if you do that, then let's say that the diagram will give you about 5 marks. Now we have the sorry. Now we have the current. Hello, Linda.
Yes.
Please, how are you?
I'm fine, please.
Welcome to the show.
Please.
Ready for the answers? Do you have the answers for us?
Yeah, actually, I'm not answering what is on the show, but I wanted to find out whether I'm having a different thing altogether.
Oh, Lynn, I can't really hear you.
What I'm saying is that I'm not solving the science question, but I want a help from English essay.
So, have you solved the problem of the day, the question of the day? Have you solved it?
No.
Oh, I thought you have solved it.
No.
But are you aware of the problem of the day?
Actually, I'm not in the house. I'm somewhere working. I just came this evening. Then my brother was watching one station and I was not happy of it. So I changed to this one and I just met where they said we should solve the question and they went on break and came.
Oh, okay. Okay.
Okay.
Yes, okay. Okay. So you have to be a friend to Joy Learning, okay?
Okay.
So always watch Joy Learning. We are on all social media platforms. Joy Learning TV. Is that okay?
Okay.
Thank you so much. Now, if you on your screen is a problem of the day. So so look at it carefully and try your hands. Linda. The questions are on your screen. So look at it carefully and try your hands. So later on, you can leave your answers with my producer and then I'll get in touch with you. Is that okay? Right. So they asked us to calculate that. Now the time is 30.6. So T is equal to 30.6 minutes. So change that into seconds and then you can do the Vivian. Hello, Vivian.
Hello.
Vivian, thank you for coming on the show.
Okay.
Do you have the solutions ready?
No, I want the meaning for.
You want? Hello?
Hello.
Yes, Vivian.
I want the meaning for water cycle.
You want what?
Meaning for water cycle.
Please, if you are ready with your solutions to the question of the day, call in and give us solutions to the question, you will win a handsome reward. Right, so with I given, T given, I can calculate the quantity of electricity. So calculating the quantity of electricity, I can have Q equal to 0.4 times 30.6 times 60. And that gives me, so it gives us the value 0.4 times 30.6 times 60. So that gives me 734.4 coulombs. So here too I can use ratio and proportion, or I can quote the formula and then do my substitution and evaluation. That's all. So if I'm using a formula, I know mass equal to IT molar mass on. Hello, Elena.
Hello, please. I want a question on the board. I can't see the question.
Oh, okay. Okay. Now the question is on the screen now. Can you see it?
No.
Can you see it?
Yeah.
Okay. Okay, so work it quickly and then give us answers for your reward. So let's do the substitution. So that I have I there is 0.4 times T 30.6 times 60. Don't forget, then the Z, we are looking at gold, so it's 3 electrons that will be transferred times Faraday 96500. So if you do that, you should get the same answers. So just do substitution and evaluation. So if you get something like this in an exams, here substitution 1 mark and then final answer 1 mark, and you are good to go. So it means that this question can be 7 marks, and you cannot afford to lose these 7 marks in an exams. Right, so let's go to our solution to the problem or the question of the day. That at the beginning of it, we read it together. So let's go back there. Okay, so this is it. So here current is given there, time is given here. And they are saying that we should write the half cell reaction equations. Oh, so none of you will get it correct for your reward. I don't want Joy to keep your award. So call in, give us answers, and then we reward you handsomely. Okay, so half cell reaction equations. You write it. H2SO4 is being electrolyzed. So you write the decomposition. Now, of course, because it is a solution, water is there. So I have H2SO4 going to 2H plus plus SO4 2 minus. Then H2 going to H plus plus OH minus. And I have reactions. So if I have that at the anode, so anode, OH will go there. So the reaction at the anode will be 4OH minus, producing 2H2O plus O2 plus 4E minus. That's all. Cathode will give me 2H plus 2 plus 2E minus producing H2 gas. So these are the half reactions. Now they say we should write the overall. So overall reaction will give me 2H2O producing 2H2 plus O2. So one there, and then one there. So that's 3. What else? So we have done that. This is alpha, that is beta, and that is A part of the question. So the B part of the question is this: calculate the volume of gas liberated at the anode and then cathode at STP. What is the time given to us? 1.6 amp, that is the current, then the time is 4.4 hours. So we can calculate the quantity of electricity that is produced. So I have Q equal to IT. So I have I 1.6 times 4.4 times 60 times 60. So that will give me coulombs. So you can use a ratio and proportion, because at the anode we transferred 4 electrons to produce 1 mole of gas, and that is 22.4. Hello, Dennis. Hello, Dennis. Hello. Hello, Dennis. Can you hear me? So we have 4 there. So it means that 4 Faraday will produce, or it's a gas. So let me use the right word. Will evolve 22.4 dm cubed of O2. So this will give me what? So you use a calculator and get it done. So I have 1.6 times 4.4 times 3600. That gives me 25,344 coulombs. Give me. So ratio and proportion. It's going to be this times that divided by 4 times Faradays. And that gives me the volume of gas evolved by 25,344 coulombs of O2 at the anode. So I'll have two 5,344 on 4 times 96,500 times 22.4. So enter that into your calculator. If you do it well, you should have 1.747 dm cubed, not per dm cubed, not per dm cubed. Dm. If it is in cm cubed, then you can have 1470 cm. You can leave it in cm cubed and you still be correct. So here too, you have 1 there, 1 there. Then at the cathode, you transferred only 2 moles of electrons to produce that. So it's going to be 2 Faraday evolves 22.4 dm cubed of H2. So 25,344 coulombs will give me that. So I'm going to have 25,344 times 22.4 all on 2 times 96,500. And that gives me. So if you do that one well, you should have 2.95 dm cubed of H2 gas. So that one to one here and then one there. Then the last part says that we should state 3 reasons for electroplating. So corrosion resistant, if you electroplate an inferior metal with a superior one, you are preventing that inferior metal from undergoing corrosion. It's for beauty purposes. And you can also use electrolysis to build objects. And then it can also serve as lubrication. The lubrication, those industries that produce food, for example, they cannot use grease for lubricating their machine parts. So you have to use electroplated metal parts for your machines so that your food will not be contaminated. So when a metal is electroplated, it becomes so smooth that it serves as lubrication. So you don't need any grease or oil for that purpose. Right. So you just state, then that will be 1, 1, 1 or 3 marks, and the total will be 10. It's rather unfortunate that nobody has received the award. Thank you so much. It's been great with you on a revision show with me, Wisdom Agbesinyale, as WC1. Keep on studying chemistry. Keep on preparing. Don't panic. Just go consistently. And at the end of the day, you come out with flying colors. We are behind you on Joy Learning. Joy Learning. Keep learning. Bye-bye.
Are you looking for a new way to revise for your WASI? Then Joy Learning has everything you need in place. Yes, we are back with the 2023 revision show for SHS 3 learners. Don't worry, your favorite question of the day section wasn't left out. And oh, you can engage with your facilitators during live TV lessons, ask questions, and get real-time feedback in the comfort of your own space. The 2023 revision show for SHS learners shows every Monday to Friday at 7:30 p.m. right here on Joy Learning. Joy Learning, learning is so fun. Joy Learning, keep learning.